Hi everybody, so in this video we're going to continue with Chapter 3, Sequences and Series, specifically with 3.2, Arithmetic Sequences. So what is an arithmetic sequence? An example of an arithmetic sequence is something like, say, 2, 5, 8, 11, 14, etc. So let's suppose it's an infinite arithmetic sequence. So what is the characteristic of an arithmetic sequence? Well, that you get the next term by adding a common term or a common difference to each of the terms. So obviously here we're adding 3 to each number, right? We add 3 to 2 to get 5, we add 3 to 5 to get 8, 3 to 8 to get 11, 3 to 11 to get 14, and so forth. So how can we generalize this? Well, let's suppose that the first term in general is a sub 1. So that would be our first term. And we have a common difference of d. So what would be the next term? Well, the next term would be a1 plus d. What would be the term after that? Well, it would be a1 plus d, so plus 2d. And the next one, well, it would be a1 plus 3d, and so forth. So here you see a pattern. So this would be the second term, this would be the third term, this would be the fourth term. So notice that the pattern here is the following. You could say that the nth term is equal to the first term. Notice that they all would have the first term, plus the index. Notice that here the index is 2, and the number multiplying d would be 1. Here the index is 3, the number multiplying d is 2. Here the index is 4, the number multiplying d is 3, and so forth. So that means that this would be the index minus 1, so n minus 1 times the common difference. So in example 3.4, they want us to find the nth term and the 50th term of the sequence 2, 11, 20, 29, 38, 47, etc. Okay, so let's remember that the formula for the nth term would be a sub n is equal to the first term plus the index minus 1 times the common difference. So what's the common difference? That's all we're missing here. Notice that it's increasing by 9, right? So 2 plus 9 is 11, 11 plus 9 is 20, etc. So that means that the nth term is going to be a sub n, first term, which we know here is 2, so 2 plus n minus 1, and in this case times 9, right? That's the common difference. So if we expand this, notice that this is going to be 2 plus 9n minus 9. So the nth term would be 9n minus 7. So 9 times n minus 7 would give us any term, and you can test it. 9 times 1, which is the first term, minus 7 would be 2. 9 times 2 is 18, minus 7 is 11. 9 times 3 is 27, minus 7 is 20, etc. So it generates the sequence. So in order to find the 50th term, all we need to do really is simply plug in 50. So this means that the 50th term is equal to 9 times 50 minus 7. And this is going to equal 443. So next we have example 3.5, and part A says find the recursive, and the explicit forms of the definition of the sequence 13, 8, 3, negative 2. So let's remember that recursive implies using the previous term to find the next term. So notice that here the common difference is a negative number because it's decreasing, and we can see that it's decreasing by 5. So that means that the common difference would be negative 5. Now, the recursive way of saying this would be the first term is 13, and the next term, or the nth term, is going to be the previous term minus 5. So that would be the recursive form of the definition of the sequence. Then the explicit form is the one we saw before, where a sub n is equal to the first term plus n minus 1 times the common difference. So here we would say first term is 13, so this plus n minus 1, and in this case the common difference is the negative number 5. And then from here we would get 13 minus 5n plus 5. So that means that the explicit form of the sequence is going to be minus 5n plus 18. And we can test that with the values and it'll work. Some people would prefer to write it as 18 minus 5n. That's preferable probably. Okay, so part B, so this was part A. Part B says calculate the value of the 25th term. So that's easy. All we have to do is plug that into the explicit form. So A of 25 is going to be 18 minus 5 times 25. So that means 18 minus 125, and that's going to equal negative 107. So now we are in example 3.6, and it says find a definition for the arithmetic sequence whose first term is 5 and fifth term is 11. So they're telling us that the first term is 5 and the fifth term is 11. So we know that the formula is a sub n, or the nth term, is equal to the first term plus n minus 1 times the common difference. So we don't have the common difference. That's something that we have to find. So how can we find it? We can plug the information here and find the common difference. So look, the fifth term is equal to 11, but it's also equal to the first term plus the index of the term minus 1. So in this case, 4 times d. And this is easy to solve because we're going to get that 11 is equal to 5 plus 4d, and then 11 minus 5 is equal to 4d. So that means that 4d is equal to 6. So d is 6 over 4, which is 3/2. So that means that we can generalize saying that the definition for the arithmetic sequence would be 5 plus n minus 1 times 3/2, and then from here we get 5 plus 3/2 n minus 3/2, and then in general the nth term would be 3/2 n plus 7/2. So that's one way of doing it. The other way of doing it would be using the recursive definition, right? So recursively, we could say the first term is equal to 5, and then the nth term is equal to the previous term plus 3/2, which is a common difference. So we have to be careful here because we have to indicate for n greater than 1 when we do the definition in this recursive form. So these would be the two ways to answer question 3.6. So next we have example 3.7, and it says insert 4 arithmetic means between 3 and 7. But what is an arithmetic mean? Well, we can find the definition here to the left, and it says in a finite arithmetic sequence, A1, A2, A3, all the way to AK, the terms A2, A3, A sub k minus 1 are called arithmetic means between A1 and AK. So basically what that means here in this case is that the first term is going to be 3, and then they want us to insert 4 arithmetic means. So that means that they want us to insert the second term, the third term, the fourth term, and the fifth term. So that means that the sixth term would be 7. So we would have to find what these values are. For that, we obviously need to find the explicit form of the definition. So remember that it's first term plus n minus 1 times the common difference. So we need to find the common difference, but we have enough information because we know that the sixth term is 7. Therefore, this is going to equal 3 plus 5 times the common difference. So that means we're going to get 4 is equal to 5d. Therefore, the common difference is 4 over 5. So once we have the formula, we can just plug in the following terms, right? Because that means that the common difference is 4/5, and we'll leave it in this form. So 4/5, let's write that here, 4/5. So what would be the second term? The second term is going to equal 3 plus 4/5. And that's going to be 15 plus 4, 19/5. The third term is going to be 3 plus 2 times 4/5, so 8/5. 8/5, and that is equal to 15 23/5. 23/5. On the next one, it's going to be the fourth term. So that would be 3 plus 3 times 4/5, so 12/5. And this will give us 27/5. And then finally, we need the fourth arithmetic mean here. It's going to be the fifth term. So that's going to be 3 plus 4 times 4/5. So that would be 16/5. And this is going to be 31/5. So there we are. Now we can insert those 4 arithmetic means.